One of the most intriguing results from this paper is how next token prediction in language models falls short on creative tasks, like generating original wordplay or designing clever math problems. It's like trying to write a story by only thinking about the next word, without stepping back to plan the whole plot. It ends up being repetitive and lacking fresh ideas.
Exactly, and the paper shows this by creating simple algorithmic tasks that mimic real-world creative challenges. These tasks require models to make a series of random decisions up front, almost like mapping out a treasure hunt before starting the journey. Instead of just predicting the next token, which is like following a straight path, the models need to explore branches and connections, revealing why next token learning memorizes too much from training data rather than innovating.
Building on that, another key finding is that multi-token approaches, such as teacherless training and diffusion models, outperform next token methods in producing diverse and original outputs. For instance, in tasks that involve drawing analogies or constructing new patterns, these models generate responses that feel more surprising and varied, like an artist freely mixing colors instead of sticking to a predefined palette.
Right, the process here involves looking ahead multiple steps at once, which is achieved through methods that encourage broader exploration. Think of it as a chef experimenting with ingredients in advance rather than deciding on the fly. Diffusion models, for example, build up the output gradually by adding and refining noise, helping the model avoid getting stuck in familiar patterns, and instead foster that eureka moment of creativity.
What's really fascinating is their discovery on handling randomness. Injecting noise directly at the input layer through something they call hash conditioning leads to better results than just tweaking the output with temperature sampling. In creative tasks, this means the model maintains coherence while still producing varied responses, almost like adding a subtle spice at the start of cooking to influence the whole dish, rather than sprinkling it on at the end.
Absolutely, and the method works by introducing variability early in the process, which allows the model to weave randomness into its core decision-making, similar to how a jazz musician improvises from the first note. Technically, hash conditioning perturbs the input in a controlled way, ensuring that the transformer architecture doesn't lose track of the bigger picture, making it a smarter way to elicit creativity without the chaos that output sampling might bring.
One more standout result is how these approaches highlight the need to go beyond just next token learning for open-ended tasks, like scientific discovery or generating novel ideas. The paper argues that by incorporating these multi-token strategies, models can better handle the implicit planning required, leading to outputs that are not only correct but truly innovative, like a detective piecing together clues in unexpected ways.
To tie that back, the accomplishment comes from designing these minimal tasks as a testing ground, where models have to orchestrate random decisions ahead of time. It's like running a simulation before the real event. This setup lets researchers see clearly how traditional methods fall short and how alternatives shine, pushing the field towards more dynamic language models.
In wrapping this up, the paper's big takeaway is that for truly creative AI, we need to move past the limitations of next token prediction and embrace methods that allow for planning and controlled randomness. This could transform how we use language models in areas like research and innovation, making them partners in generating fresh, original ideas rather than just echoing what's been seen before.
Exactly. So overall, this work underscores the importance of rethinking language model training for open-ended creativity. By focusing on these leap-of-thought tasks, it's a step towards AI that can surprise us with new connections, much like how human creativity sparks from exploration and planning. Definitely food for thought for anyone in ML research.